discovered by Hans Lippershey, but invented actually by Galileo Galilei. And this is a photo. This particular photo that you can see on the left side is taken by the Curiosity rover that is presently on the Mars. Here you can see the Earth in the Martian sky, and this photo in the right, you can see Mars in the Earth sky. And this is a photo of Mars taken by the Hubble telescope in its initial stages. Yeah. And this is the most amazing thing that I can see on the Martian surface, the fossils of the bacteria that were present on the Mars millions of years ago. And how did the planets look like 3.8 billion years ago? And this is a true image of
Wow.
Mars, of how we will see with our eyes, taken by our ISRO. And those photos they can see with Mars in a ruddy color is actually edited. And then the question was, which among the following has the highest mountain? So the answer is yes, Vesta. So these are the Vesta, and the photo in the right one is of Olympus Mons. And there is a competition going on in between these two to be declared as the highest mountain of the solar system. And the next question, which man-made satellite has reached furthest from the sun? Is Voyager 1, launched in 1977 on 5th September. It is the first man-made satellite to cross the heliosphere, which it crossed it on 5th December 2011, and it is still now active, but it is consuming a lot of power to interpret the data sent by this probe on the Earth.
Oh, gotcha. ऐसा है क्या? Wow, wow, very nice. Cool.
So now we saw that the comparisons between Mars and Earth. So Mars is the fourth planet, and Earth is the third planet. Mars is very small as compared to Earth, and also it is half the size of the Earth. Here you can see is in this image the Mars is actually put in front of the Earth for just comparison. And in this image we can see this is the perpendicular to the ecliptic of the orbital plane of in which the planet revolves around the sun, and this is the rotational axis, the axis around which the planet revolves, and this
Wow.
equator is the perpendicular to the rotational axis.
Hmm.
And here we saw that Mars doesn't have much stable axis because it is very small and it does not have any companion like moon to make it stable, so it like spins around it freely in the space. And because of this changes in the tilt, the ice distribution on the surface of the Mars also changes. So here you can see the actually half of the planet's surface is covered with ice. And in this image you can see this mist like thing. These are methane clouds of methane gas that even means sometimes arises on Mars because of some specific weather conditions. And yes, Mars axis of rotation is tilted 25.2 degrees relative to the plane of the planet's orbit around the sun, which helps give Mars similar seasons to those on Earth. And whichever hemisphere is tilted closer to the sun experiences spring and summer, while the hemisphere tilted away gets fall and winter. And Mars also has 2 days called the equinoxes, when the duration of day and night are almost equal. And then the year Yes, the Mars is about 50% farther from the sun than the Earth is, and that's why it takes 687 Earth days for Mars to orbit once around the sun. And an individual season can last up to 194 sols or just over 199 Earth days, and sols are short form of a solar day. And in this image, you can see the transitions
Hmm.
of the on the surface of the Mars with respect to the weathers and particular moments of the year.
Okay.
Here you can see the comparison between the axial tilt of Mars and Earth. You can see that there is very less difference in these tilts, and that is the reason why Mars has so much similar seasons to that of the Earth. And this is the third
Hmm.
question, which planet of the solar system has the highest obliquity. We saw it is Venus. Yeah, it rotates all in exactly opposite directions with respect to the other planets. And then these are the cosmic companions of the Mars. This is Deimos and this is Phobos. Deimos is the smaller and Phobos is the bigger. These are the believed to be captured by Mars from the asteroid belt, or these were just flung up into the space by large cosmic impacts that happened on the Mars long ago. And here you can see that there are many grooves and craters on the Pho- Phobos, which is the bigger moon of the Mars. And these lines that you can see, these are actually very weird looking because it is it is believed to be the stretch marks or tension marks caused by the Mars's gravitational force that acts on the Phobos, because Phobos is very close to its planet. It's, I don't remember how much. It's at 30,000 kilometers or something.
Hmm. Chalo, yeah, it's okay. Mhm.
This is this crater that you can see, it is very big, and something, this is the crater that from which the material flung up into this maze, and it was crashed back onto the moon itself, which caused these these craters. And here you can see the
Hmm.
relative size of the planet and from its moons. And this is an image taken by one more rover or satellite. This is in this image you can see solar eclipse caused by the Phobos. And in this picture, you can see the
Yeah.
comparison between Earth's moon and Mars' moon. You can see that Phobos' mean radius is just 11.3 kilometers, and that of the our moon, Luna, is 1,737 kilometers,
Hmm.
100 times greater.
It's good. Correct, correct.
And then our fourth question:
22 kilometers.
in which country were the first ever rockets launched? And yes, it is India. The Mysorean army,
India, Tipu Sultan.
Hyder Ali, the son of Tipu Sultan, launched the rockets in 1780s in 1780s in a war against the British India Company. And this conflict exposed the British to this technology. This proves that rocket technology has also arisen from India. And then we discuss the challenges. First challenge is the traveling distance. Yes,
Uh-huh.
the distance between Mars and Earth is roughly 54 million miles. So once every 26 months, Earth and Mars align in a way that minimizes the travel times and expense, enabling spacecraft to make the interplanetary journey in roughly half a year. And the Mars missions that we put now into the space are also conducted during this event or conjuncture.
Hmm.
And here you can see, You can see the interplanetary projection. In this TCM is short form for trajectory correction, trajectory connect correction maneuvers. Yeah, maneuvers are movements for that are done because of that are done to erase the errors between for the trajectory.
Hmm. Nice. They are taking 17 days. Hmm.
So just like we have to wait for Earth and Mars to be in the proper position before we head to Mars, we also have to make sure that they are in proper position before we head back home. This means the first
श्रेयस देख ले कैसे जाने का है.
will have to spend 3 to 4 months at Mars before they can begin the return trip. And all in all, this trip to Mars would take about 20 to 21 months, 9 months to get there, 3 months living there, and 9 months to get back home. So yeah, this is his Satyendranath Bose, the great physicist.
200 दिन लगभग लगेंगे पहुंचने को मार्स पे.
And this is a very interesting observation done by someone. Sorry. So next we talk about the monsters. So let's continue from talking about the monsters. And who are these monsters? These are the rockets that will take us to the red planet. So first we'll talk about NASA's SLS.
श्रेयस सोच ले जाएगा तो 9 महीना जानने के लिए 9 महीना आने के लिए.
बहुत टाइम लग जाएगा.
Okay, Krishna is back, and by the time he opens the screen, and 3 months we have to stay there. भैया 9 महीना actually यार अभी घर में रह रहे. Yeah, Krishna, we can hear you.
Yes, Krishna.
So it was a network
तो अभी हाँ नहीं we understand. 16 महीने तो ऐसे घर में बैठे हम लोग. तो 9 महीना अमन मजा आएगा यार, मतलब नया जगह देखने का एक्साइटमेंट चलेगा. वो तो अभी शुरुआत है, अभी 9 months का है, बट आई थिंक आगे जाके थोड़ा पावरफुल रॉकेट्स बनेंगे ना, बूस्टर है ना.
सर आपने बोला था थोड़े सालों बाद 30,000 40,000 का हो जाएगा पर टिकट प्राइस.
अरे वो इसके लिए नहीं रहे बाबा, मार्स मिशन के लिए बोल रहा था मैं, स्पेस मिशन के लिए. अभी वो वर्जिन गैलेक्टिक वाला कितने में बेच रहा है. वंस मैंने भेजा ना वो स्लाइड्स, देख ले जरा उसमें रेट क्या है करके, एंड मुझे लगता है 2-3 लाख पे आ सकता है. ओके, कंटिन्यू कृष्णा. 2 लाख 1 stands 100,000 10,000 लाख 10 लाख. मेरे ख्याल से $25 million था शायद. 25 की 30 में $25 million शायद. कितना था वो टिकट? मैंने वो फोटो भेजा है अपने ग्रुप पे, भेजा है मैंने. मेरे को मैं देख के बताता हूँ.
Hello.
Sir, Krishna is mute.
Yeah, I can. Yeah, Krishna, we can hear you now.
हाँ कृष्णा, आवाज आ रही है तेरी.
Yes. So NASA has been developing a huge rocket called the Space Launch System, the SLS, to launch astronauts for initial stages to the moon and then eventually to Mars. So it is believed to make its debut in November of this year. So it is modern equivalent to the Saturn V rocket launched in the 1960s to take the moon to take the astronauts to the moons. And this will be the biggest rocket launched after the Saturn V, last in the Apollo 17 mission in 1972. The first version of the SLS will be called SLS Block 1. So it will undergo a series of upgrades in coming years so that it can launch heavier payloads to destinations beyond low Earth orbit and eventually to Mars. So this rocket will launch astronauts in NASA's next generation crew vehicle Orion, boosting it to the speeds necessary to break out of the low Earth orbit and travel onwards to the moon and further away. So now we will see how it works. So this SLS consists of a giant core stage flanked by two solid rocket boosters. The core houses two large storage tanks filled with one for liquid oxygen and another for liquid hydrogen. So oxygen is the oxidizer which makes the fuel burn, and together the fuel and the oxidizer are called propellants. And at the base of this SLS core stage,
What they are called?
what? Hello.
Yeah, हाँ कृष्णा, I can hear you.
Yeah, what did he say?
नहीं, I can hear you. अरे अमन, एक सेकंड है कृष्णा, 2 करोड़ रुपए की 1.75 करोड़ टिकट है वर्जिन अटलांटिक का, वर्जिन सॉरी VSS यूनिटी का। $2.5 लाख कितना होता है? 2 करोड़ रुपए होता है अभी। 1.75 करोड़ तो ज्यादा नहीं है एक्चुअली। एनीवे, स्विच में कंटिन्यू।
So here you can see the different stages. These are the SRBs, the solid rocket boosters. These are the two RS-25 engines, and this is the core stage. This is the adapter, vehicle launch vehicle adapter. This is interim cryogenic propulsion stage that will make the Orion capsule break through the Earth's gravitational force into the space. And this is very important thing in these type of missions, the launch abort system. So
हाँ,
when
लॉन्च अबॉर्ट सिस्टम, कल को कुछ एक्सीडेंट हो गया तो बचने के लिए वो काम में आता है।
so when liquid hydrogen and
उसमें हम लोग है ना ऊपर वाले
fed into the
ओके
engine
कंटिन्यू।
chamber
हाँ
and ignited with a spark, the the chemical reaction produces vast amounts of energy and steam. The steam exits engine nozzles at the speed of 16,000 kilometers per hour or 10,000 miles per hour to generate the
बाप
thrust.
रे,
And
हद
the
है ये तो।
SRBs give the rocket extra power to escape gravity's clutches. And in the yeah,